Hey everyone, this might seem a bit unexpected, but since I recently was laid off, I figured what's the better way to prepare for upcoming interviews than to learn in public and record videos about the material I'm studying. Today we're diving into MCP or Model Context Protocol and breaking down exactly how it works. And here is the first piece of advice: never skimp on microphones. But okay, let's go. For years, the most famous protocol everyone has heard of has been HTTP. API built on this protocol. It acts as a universal handshake between systems where developers define an endpoint, users send a request, and a clean, predictable response comes back. For traditional software, the design is perfect. Then large language models arrived and changed everything. Unlike traditional software, models don't natively know how to call functions. Developers had to manually define tools, write API code, parse responses, and hard-coded the connection for every single AI platform. Switching the platform or adding services meant repeating this entire process from scratch. This custom redundant wiring is a real bottleneck. To solve this, Anthropic introduced the Model Context Protocol (MCP) in November 2024 as an open standard, designed to let models autonomously find and use tools without constant manual assistance. You can think of MCP like a USB port. Before USB, every device had its own proprietary connector, a special plug for each individual device. USB solved this by giving everyone one standard port. However, USB didn't replace the device itself. USB simply standardized how you plug it in. MCP is just a standard interface on top of real mechanism doing the work. It never replaces it. Furthermore, that underlying mechanism doesn't even have to be a REST API. It could easily be a database, file system, or local commands. Before going any deeper into how this works, there is one thing worth understanding clearly. An AI is just a language model. It has no hands. The only thing it can do is produce text. It cannot open a connection, run a process, or send a network packet. Everything else is traditional software running on our machines. First, there is a host app like Cloud or Cursor, which reads the AI request and acts on it. This is where the MCP client lives. Second, there is a MCP server, which is a separate program often written by a third party like Atlassian for Jira. Finally, there is a real service living on the internet like Jira, Gmail, or whatever. To picture this, imagine your mom is holding a camera in front of laptop while you're telling her to click a specific button. She's doing all the actual physical clicking. You are just producing the instructions. In this scenario, you're the AI, the host app is your mom, and the MCP is simply the language you both agree to use. Instead of the model being manually taught about each endpoint, MCP gives it a standardized way to discover what a tool can do, what inputs it expects, and what output it returns, all through context. Each service exposes an MCP-compatible interface, allowing the model to discover these tools automatically and understand their functions as part of its environment. That's the core difference. API is core-level contract between two applications, where MCP is a semantic protocol between a model and its environment. Under the hood, an MCP server is a lightweight process that sits right next to your service or data source, describing what it can do using JSON schemas. The model connects to the server through a standardized interface like WebSocket or HTTP and receives metadata about the available tools. Once connected, the model calls this function directly using that metadata. This server setup is typically just two files: config.json, a small file that lives in the host settings, which tells the host where and how to reach the server, and second, server code, the actual program. This can be local, a file on disk launched by a command, or remote, deployed as part of the application and reached by URL. For example, a configuration file for Playwright MCP looks like this. And here is a minimal Python MCP server wrapping the TestRail API. In the next videos, we'll go deeper into how the MCP host, client, and server operate together. We'll also look at why Python is used more often than other languages for MCP servers and how to work with services that don't have MCP support yet. Bye!